Welcome to solverfy.
For this question, we are going to be using the balanced equations for flue-gas desulfurization. They are wanting us to find, for the first part of this question, the mass of calcium sulfate that can be obtained from 4 gigaliters of flue gas. So they tell us that we have 4 gigaliters of flue gas, and they're wanting us to find out how much calcium sulfate in kilograms we can obtain from this. So we know that 1 gigaliter is equal to 1 times 10 to the 9 liters. So we know that 4 gigaliters is equal to 1 times 10 to the 9 liters over 1 gigaliter. So we have 4 times 10 to the 9th liters of flue gas. All right, so to help us find the mass of calcium sulfate, we first need to find the moles of flue gas that we have. So moles flue gas. And so for this, we're going to be using PV is equal to nRT. We want to find the moles, so N is equal to PV over RT. And they tell us that our pressure is equal to 1 atmosphere, and that our temperature is equal to 25 degrees Celsius. I'm just going to add 273 Kelvin to this. So our temperature is going to be 298 Kelvin. All right, so we're just going to plug everything into our equation. So 1 atmosphere times our volume, so 4 times 10 to the 9 liters. We're going to divide this by R, so I'm just going to use R, 0.0821 liters atmosphere per mole Kelvin, and then we are going to times that by our temperature, so 298 Kelvin. All right, so when we calculate this out, our moles of flue gas is going to equal to 1.635 times 10 to the 8 moles of our flue gas. So now that we have our moles of flue gas, we need to find a connection between the moles of flue gas and our mass of our calcium sulfate. So if we go up here, we see that 1 mole of our sulfur dioxide is equal to 1 mole of our calcium sulfate. So we're going to use that connection to help us find the mass of our calcium sulfate. So we need to find the moles of our sulfur dioxide, and they give us the mole fraction for sulfur dioxide. They say it's 1,000 times that of clean air, and we know that the mole fraction for clean air is 2 times 10 to the negative 10. So our mole fraction for SO2 is equal to 2 times 10 to the negative 10 times 1,000. So our new mole fraction for SO2 is going to be 2 times 10 to the negative 7. All right, and we know our moles of sulfur dioxide is equal to its mole fraction times the total number of moles. So we do know the total number of moles, it's how many moles of our flue gas we have. So our moles of SO2 is going to be 2 times 10 to the negative 7 times 1.635 times 10 to the 8 moles. So our moles of sulfur dioxide is going to be 32.7 moles. So now that we have our moles of sulfur dioxide, we can get our moles of our calcium sulfate, and that's just going to be our moles of our sulfur dioxide, and we're going to times that by that 1-to-1 mole ratio, so 1 mole calcium sulfate to 1 mole sulfur dioxide. So our moles of our calcium sulfate is the same, 32.7 moles. So now to get the mass of our calcium sulfate, we just take our number of moles, so 32.7 moles, and we're just going to times that by its molar mass, which is 136.14 grams per mole. So our mass of calcium sulfate is equal to 4,451.8 grams. They want this in kilograms, so we're just going to divide this by 1,000. So when we do that, it's going to equal 4.4518 kilograms of our calcium sulfate. And this is the amount or the mass of calcium sulfate we can get from 4 gigaliters of flue gas. All right, so for the second part of this question, they're asking us the volume of air needed to react with all of the calcium sulfite. So to figure that out, we're going to need to figure out the moles of O2. They do give us the mole fraction for O2, and it's equal to 0.209. And then we're looking for the volume of air in liters. All right, so we know that moles of O2 is equal to its mole fraction times the total moles of air. So our moles of O2 is going to be 0.209 times 100 moles of air. So our moles of O2 is going to be 0.209 moles O2. So now that we have our moles of O2, let's get our moles of the calcium sulfite. So we know that if we go back up here to our balanced chemical equations, we see that 1 mole of the calcium sulfite goes to 1 mole of our sulfur dioxide. We already know the moles of our sulfur dioxide, so let's just use that number for our molar ratio to figure out our moles of calcium sulfite. So we're going to use 32.7 moles of our calcium sulfite, because it's just going to be a 1-to-1 ratio. And we know that for every 1.5 mole of O2, we have 1 mole of our calcium sulfite. And then we also know that for every 1 mole of air, we have 0.209 moles of O2. So when we calculate this out, our moles of air is going to equal 78.2 moles of air. So then to get the volume, we're just going to use PV is equal to nRT. So we're solving for volume, so nRT divided by the pressure. They tell us that the pressure is equal to 1 atmosphere, and we're going to be using a temperature equal to 298 Kelvin. So our volume is going to equal 78.2 moles of air. We're going to times that by our R value, which is 0.0821 liters atmosphere per mole Kelvin. We're going to times that by our temperature, which is 298 Kelvin. And we're going to divide all of this by 1 atmosphere. So our volume of air is going to equal 1,913 liters of air that is needed to react fully with calcium sulfite. And that's how we solve the second part of this problem.